non-zero digit, 1 of 120.
The streaming software started to crash at like, I don't know, 11 hours, 44 minutes. So I had to like restart. I don't know. I think it's working. Crashes aren't anything new.
Literal.
It's like pretty standard when it comes to
Binary digits SEP. Binary digits SEP.
this modern
SEP. Binary digit.
this modern streaming software crashes. They're like the coup de grace. What is it? Is it coup de grace? I don't know. They're like the bee's knees. I don't even know. It's 2024. No, it's 2025. Yeah. It's very modern software. Crashes and stuff. That's hip in style. Pizza before ate pizza before school. You know, like super hip. Okay, so I'm gonna shut up and I want to finish converting this JavaScript to run my JavaScript engine to speed test it. But the stream was like, there's no way I can make it in the 12-hour time span. So now I have to waste a tiny little stream as I finish up this code. So that's what I'm gonna do. I don't know. I'll play music and try to get done like now because it's taking too long. I want to speed test and compare my JavaScript engine to Chrome or whatever. I don't know. I had something else to say. It was I forgot. If I remember it, it doesn't matter. Anyways, I'm gonna just finish up whatever. I lost my focus. I had to focus again. I don't know if that's gonna happen. Possibly not. It's great.
Octal digit, octal digit.
I should like just say things and then whisper off to the side. Like I'm talking to myself. Alright, I'm gonna get to work now. I'm gonna get to work now. No, I'm joking. It's creepy. I gotta stop doing that.
0x hex.
Not as creepy as the guy that said, my butt's been wiped. That's pretty creepy. That's like really creepy. Who says your butt's been wiped? It's real creepy. You can't go around telling people your butt's been wiped. It's not even funny. It's disgusting. Who wiped your butt? Okay. I'm gonna focus. Now.
Static semantics. Early errors. Numeric literal. Legacy octal, integer literal, decimal, integer literal. Non-octal, decimal, integer literal.
In a second, I gotta check the video settings.
Code. Note to non-strict code. Taxes legacy. 3, 2 stack.
Hit save and it's spinning. Oh, it says change usage. Alright, now focus.
Decimal, integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits, excluding all occurrences of...
I gotta like pull up the browser. That's on my teeth.
Is the MV of exponent part, the MV of decimal literal.
Claritin. Freaking trees outside. Pollinating the air.
Plus the MV of decimal digits 10n.
Pollination should be illegal.
Excluding all occurrences.
You can't just have like tree sex in the air.
Literal.
And we'll all just breathe it in. It's not cool.
N is the number of code points in decimal.
Trees should be like grouped up together and like throw a blanket over like the two trees and let them pollinate and keep the pollen out of the air.
code points in decimal.
We don't need to breathe pollen. There's no reason for pollen to be in the air. Alright, I'm gonna try to focus. Right now, I'm gonna focus. I hate everything.
The envy of decimal integer literal. 0.
I hate trees, most of all. Screw trees
Numeric literal.
and their damn pollination.
Of non-zero digit 10n plus the envy of decimal digits, where n is the number of code points in decimal.
I hate trees and ragweed and dust. Ugh.
Envy of decimal digits plus the envy.
But peanut butter's cool. I'm not allergic to that. Peanut butter? That's awesome. I like it.
Is the envy of decimal digits 10 plus the envy of decimal digit. The envy of exponent part. Exponent indicate a signed integer as the envy of signed integer. The envy of signed integer. Decimal digits is the negative of the envy of decimal digits. The envy of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0, the envy of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the envy of decimal digit. 2 or of non-zero digit, the envy of decimal digit. 3 or of non-zero digit, the envy of decimal digit. 4 or of non-zero digit, the envy of decimal digit. 5 or of non-zero digit, the envy of decimal digit. 6 or of non-zero digit, the envy of decimal digit. 7 or of non-zero digit, the envy of decimal digit. 8 or of non-zero digit, the envy of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the envy of hex digit, or of hex digit. A is 10, the envy of hex digit. B or of hex digit. B is 11, the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of binary digits. Binary digit is the envy of binary digits 2 plus the envy of binary digit. The envy of binary digits. Binary digits numeric literal separator binary digit is the envy of binary digits plus the envy of binary digit. The envy of octal digits. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of octal digits. Octal digits numeric literal separator octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of legacy octal integer literal. Legacy octal integer literal octal digit is the envy of legacy octal integer literal times 8 plus the envy of octal digit. The envy of non-octal decimal integer literal. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Non-octal digit is the envy of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of non-octal digit. The MV of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the MV of non-octal decimal integer literal times 10 plus the MV of decimal digit. The MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit is the MV of capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, times 10 plus the MV of octal digit. The MV of hex digits. Hex digit is the MV of hex digits 16 plus the MV of hex digit. The MV of hex digits. Hex digits numeric literal separator hex digit is the MV of hex digits 16 plus the MV of hex digit 2, 9, 3, 3 static semantics. Numeric value. The syntax-directed operation numeric value takes no arguments and returns a number or a big int. It is defined piecewise over the following productions. Numeric literal, decimal literal, return round MV result, MV of decimal literal. Numeric literal, non-decimal integer literal, return, MV of non-decimal integer literal. Numeric literal, legacy octal integer literal, return, MV of legacy octal integer literal. Numeric literal, non-decimal integer literal big int literal suffix, return the big int value for the MV of non-decimal integer literal. ECMA International 2024 229. Decimal big integer literal. 0 big int literal suffix 1. Return 0z. Decimal big integer literal. Non-zero digit big int literal suffix 1. Return the big int value for the MV of non-zero digit. Decimal big integer literal. Non-zero digit decimal digits big int literal suffix. Non-zero digit numeric literal separator decimal digits big int literal suffix. Let n be the number of code points in decimal digits, excluding all occurrences of numeric literal separator. Let nv be the MV of non-zero digit 10n plus the MV of decimal digits. Return z. MV 2, 9. 4 string literals. Note 1. A string literal is 0 or more Unicode code points enclosed in single or double quotes. Unicode code points may also be represented by an escape sequence. All code points may appear literally in a string literal except for the closing quote code points. U plus 005C, reverse solidus, U plus 000D, carriage return, and U plus 000 line feed. Any code points may appear in the form of an escape sequence. String literals evaluate to ECMAScript string values. When generating these string values, Unicode code points are UTF-16 encoded as defined in 1111. Code points belonging to the basic multilingual plane are encoded as a single code unit element of the string. All other code points are encoded as 2 code unit elements of the string. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character, double string character sopt, single string characters, single string character sopt, double string character, source character but not one of or line terminator. ls, ps, escape sequence, line continuation, single string character, source character but not one of or line terminator, ls, ps, escape sequence, line continuation, line terminator sequence, 30, ECMA International 2024, escape sequence, character escape sequence, look ahead decimal digit, legacy octal escape sequence, non-octal decimal escape sequence, hex escape sequence, Unicode escape sequence, character escape sequence, single escape character, non-escape character, single escape character, one of BFNRTV, non-escape character, source character but not one of escape character or line terminator, escape character, single escape character, decimal digit, XU, legacy octal escape sequence, 0, look ahead, 8, 9, non-zero octal digit, look ahead octal digit, 0 to 3, E octal digit, look ahead octal digit, 4 to 7 octal digit, 0 to 3 octal digit, non-zero octal digit but not 0, 0 to 3, 1 of 0, 1 to 3, 4 to 7, 1 of 4567, non-octal decimal escape sequence, 1 of 89, hex escape sequence, X hex digit, Unicode escape sequence, U hex 4 digits, U, code point, hex 4 digits, hex digit. The definition of the non-terminal hex digit is given in 129.3. Source character is defined in 11.1. ECMA International 2024 231. Note 2. LF and CR cannot appear in a string literal, except as part of a line continuation to produce the empty code point sequence. The proper way to include either in the string value of a string literal is to use an escape sequence such as N or U000 2, 9, 4, 1 static semantics, early errors, escape sequence, legacy octal escape sequence, non-octal decimal escape sequence. It is a syntax error if the source text matched by this production is strict mode code. Note 1 in non-strict code. This syntax is legacy 2, 9, 4, to static semantics, SV. The syntax-directed operation SV takes no arguments and returns a string. A string literal stands for a value of the string type. SV produces string values for string literals through recursive application on the various parts of the string literal. As part of this process, some Unicode code points within the string literal are interpreted as having a mathematical value, as described below or in 129.3. The SV of string literal is the empty string. The SV of string literal is the empty string. The SV of double string characters is the string. Concatenation of the SV of double string character and the SV of double string characters. The SV of single string characters is the string. Concatenation of the SV of single string character and the SV of single string characters. The SV of double string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of double string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of double string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of double string character, line continuation is the empty string. The SV of single string character, source character but not one of or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The SV of single string character, ls, is the string value consisting of the code unit 0 times 2028. Line separator. The SV of single string character, ps, is the string value consisting of the code unit 0 times 2029. Paragraph separator. The SV of single string character, line continuation is the empty string. The SV of escape sequence, 0 is the string value consisting of the code unit 0 times 0000. Null. The SV of character escape sequence, single escape character is the string value consisting of the code unit whose numeric value is determined by the single escape character according to table 38. Note to it is possible for string literals to precede a use strict directive that places the enclosing code in strict mode, and implementations must take care to enforce the above rules for such literals. For example, the following source text contains a syntax error, function invalid. 7. Use strict. 32. Copyright sign. ECMA International 2024. Table 38. String single character escape sequences. Escape sequence. Code unit value. Unicode character name. Symbol B 0 times 0008. Backspace BS T 0 times 0009. Character tabulation HT N 0 times 000 line feed. LF V 0 times 000B line tabulation VT F 0 times 000C form feed FF R 0 times 000D carriage return CR double quote 0 times 0022 quotation mark apostrophe 0 times 0027 apostrophe backslash 0 times 005C reverse solidus comma the SV of non-escape character, source character but not one of escape character or line terminator as the result of performing UTF-16 encode code point on the code point matched by source character. The SV of escape sequence. Legacy octal escape sequence is the string value consisting of the code unit whose numeric value is the NV of legacy octal escape sequence. The SV of non-octal decimal escape sequence. 8 is the string value consisting of the code unit 0 times 0038, digit 8, the SV of non-octal decimal escape sequence. 9 is the string value consisting of the code unit 0 times 0039, digit 9, the SV of hex escape sequence. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex escape sequence. The SV of hex 4 digits. Hex digit is the string value consisting of the code unit whose numeric value is the NV of hex 4 digits. The SV of Unicode escape sequence, U, code point, is the result of performing UTF-16 encode code point on the NV of code point. The SV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0000, null 1 2, 9, 4. 3 static semantics, MV, the MV of legacy octal escape sequence, 0 to 3 octal digit is 8 times the MV of 0 to 3 plus the MV of octal digit. The MV of legacy octal escape sequence, 4 to 7 octal digit is 8 times the MV of 4 to 7 plus the MV of octal digit. The MV of legacy octal escape sequence, 0 to 3 octal digit is 64. That is 82. Times the MV of 0 to 3 plus 8 times the MV of the first octal digit plus the MV of the second octal digit. The MV of 0 to 3. 0 is 0. The MV of 0 to 3. 1 is 1. The MV of 0 to 3. 2 is 2. The MV of 0 to 3. 3 is 3. The MV of 4 to 7. 4 is 4. The MV of 4 to 7. 5 is 5. The MV of 4 to 7. 6 is 6. The MV of 4 to 7. 7 is 7. The MV of hex escape sequence. Hex digit is 16 times the MV of the first hex digit plus the MV of the second hex digit. The MV of hex 4 digits. Hex digit is 0 times 1000 the MV of the first hex digit, plus 0 times 100 the MV of the second hex digit plus 0 times 10 the MV of the third hex digit plus the MV of the fourth hex digit. ECMA International 2024 233 1 2 9 5 regular expression literals. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The source text comprising the regular expression body and the regular expression flags are subsequently parsed again using the more stringent ECMAScript regular expression grammar. 2.2.2.1. An implementation may extend the ECMAScript regular expression grammar defined in 2.2.2.1. but it must not extend the regular expression body and regular expression flags productions defined below or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags, regular expression body, regular expression first char, regular expression chars, regular expression chars. Empty, regular expression chars, regular expression char, regular expression first char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, regular expression char, regular expression non-terminator but not one of or. Capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression class, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U, regular expression non-terminator, regular expression non-terminator, source character but not line terminator, regular expression class chars, regular expression class chars. Empty, regular expression class chars, regular expression class char, regular expression class char, regular expression non-terminator but not one of or, capital R E G U L A R, capital E X P R E S S I O N, capital B A C K S L A S H, capital S E Q U. Note 1. A regular expression literal is an input element that is converted to a regexp object. See 22.2 each time the literal is evaluated. Two regular expression literals in a program evaluate two regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp or calling the regexp constructor as a function. C22, 34. ECMA International 2024. Regular expression flags. Empty. Regular expression flags identify part char 2, 9, 5, 1 static semantics. Body text. The syntax-directed operation body text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression body 1, 2, 9, 5. To static semantics. Flag text. The syntax-directed operation flag text takes no arguments and returns source text. It is defined piecewise over the following productions: regular expression literal, regular expression body, regular expression flags. Return the source text that was recognized as regular expression flags 1, 2, 9, 6. Template literal lexical components. Syntax. Template. No substitution template. Template head. No substitution template. Template character sop. Template head. Template character sop. $. Template substitution tail. Template middle. Template tail. Template middle. Template character sop. $. Template tail. Template character sop. Template characters. Template character. Template character sopt. Note 2. Regular expression literals may not be empty. Instead of representing an empty regular expression literal, the code unit sequence starts a single line comment. To specify an empty regular expression, use dart. ECMA International 2024 235. Template character. Look ahead. Template escape sequence. Not escape sequence. Line continuation. Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit but not 0. X. Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex digit hex digit. Look ahead hex digit. U. Look ahead hex digit. U. Not code point. Look ahead hex digit. U. Code point. Look ahead hex digit. Look ahead not code point. Hex digits. Sep. But only if MV of hex digits. 0 times 10ff. Code point. Hex digits. Sep. But only if MV of hex digits 0 times 10ff. Note template substitution tailors used by the input element template tail alternative lexical goal 1 2 9 6 1 static semantics. TV. The syntax directed operation TV takes no arguments and returns a string or undefined. A template literal component is interpreted by TV as a value of the string type. TV is used to construct the index components of a template object, colloquially, the template values. In TV, escape sequences are replaced by the UTF-16 code units of the Unicode code point represented by the escape sequence. The TV of no substitution template is the empty string. The TV of template head, $, is the empty string. The TV of template middle, $, is the empty string. The TV of template tail is the empty string. The TV of template characters, template characters is undefined if the TV of template character is undefined or the TV of template characters is undefined. Otherwise, it is the string concatenation of the TV of template character and the TV of template characters. The TV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TV of templar, T character, $sign is the string value consisting of the code unit 0 times 0024. $, the TV of template character, template escape sequences the SV of template escape sequence, the TV of template character, not escape sequence is undefined, the TV of template character, line terminator sequences the TRV of line terminator sequence, 236, copyright sign, ECMA International 2024, the TV of line continuation, line terminator sequences the empty string 1 2 9 6 to static semantics. TRV. The syntax-directed operation TRV takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type. TRV is used to construct the raw components of a template object, colloquially, the template raw values. TRV is similar to TV with the difference being that in TRV, escape sequences are interpreted as they appear in the literal. The TRV of no substitution template is the empty string. The TRV of template head, $, is the empty string. The TRV of template middle, $, is the empty string. The TRV of template tail is the empty string. The TRV of template characters, template characters is the string concatenation of the TRV of template character and the TRV of template characters. The TRV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by source character. The TRV of template character, $, is the string value consisting of the code unit 0 times 0024. $, the TRV of template character, template escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of template escape sequence, the TRV of template character, not escape sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of not escape sequence, the TRV of template escape sequence, 0 is the string value consisting of the code unit 0 times 0030, digit 0, the TRV of not escape sequence. 0 decimal digit is the string concatenation of the code unit 0 times 0030, digit 0, and the TRV of decimal digit. The TRV of not escape sequence. X, look ahead hex digit, is the string value consisting of the code unit 0 times 0078, Latin small letter x, the TRV of not escape sequence. X hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0078, Latin small letter x, and the TRV of hex digit. The TRV of not escape sequence. U, look ahead hex digit, look ahead, is the string value consisting of the code unit 0 times 0075, Latin small letter u, the TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex digit. The TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, and the TRVO F the second hex digit. The TRV of not escape sequence. U hex digit, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the TRV of the first hex digit, the TRV of the second hex digit, and the TRV of the third hex digit. The TRV of not escape sequence. U, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the code unit 0 times 007b, left curly bracket. The TRV of not escape sequence. U, not code point, look ahead hex digit, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRV of not code point. The TRV of not escape sequence. U, code point, look ahead hex digit, look ahead, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, and the TRV of code point. The TRV of decimal digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of character escape sequence. Non-escape character is the SV of non-escape character. The TRV of single escape character. 1 of BFNRTV is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of hex escape sequence. X hex digit is the string concatenation of the code unit 0 times 0078, Latin small letter x, the TRV of the first hex digit, and the TRV of the second hex digit. The TRV of Unicode escape sequence. U hex 4 digits is the string concatenation of the code unit 0 times 0075, Latin small letter u, and the TRV of hex 4 digits. The TRV of Unicode escape sequence. U, code point, is the string concatenation of the code unit 0 times 0075, Latin small letter u, the code unit 0 times 007b, left curly bracket, the TRV of ECMA International 2024-237, code point, and the code unit 0 times 007d, right curly bracket, the TRV of hex 4 digits. Hex digit is the string concatenation of the TRV of the first hex digit, the TRV of the second hex digit, the TRV of the third hex digit, and the TRV of the fourth hex digit. The TRV of hex digits. Hex digit is the string concatenation of the TRV of hex digits and the TRV of hex digit. The TRV of hex digit. 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 ABCDEF. ABCDEF is the result of performing UTF-16 encode code point on the single code point matched by this production. The TRV of line continuation. Line terminator sequences the string concatenation of the code unit 0 times 005C, reverse solidus, and the TRV of line terminator sequence. The TRV of line terminator sequence, LF, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, CR, is the string value consisting of the code unit 0 times 000 line feed. The TRV of line terminator sequence, LS, is the string value consisting of the code unit 0 times 2028 line separator. The TRV of line terminator sequence, PS, is the string value consisting of the code unit 0 times 2029 paragraph separator. The TRV of line terminator sequence, CRLF, is the string value consisting of the code unit 0 times 000 line feed. 2.10 Automatic semicolon insertion. Most ECMAScript statements and declarations must be terminated with a semicolon. Such semicolons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described by saying that semicolons are automatically inserted into the source code token stream in those situations. 2.1.0.1 Rules of automatic semicolon insertion. In the following rules, token means the actual recognized lexical token determined using the current lexical goal symbol as described in clause 12. There are three basic rules of semicolon insertion. When, as the source text is passed from left to right, a token, called the offending token, is encountered that is not allowed by any production of the grammar, then a semicolon is automatically inserted before the offending token if one or more of the following conditions is true. The offending token is separated from the previous token by at least one line terminator. The offending token is, the previous token is, and the inserted semicolon would then be passed as the terminating semicolon of a do-while statement 1.4.7.2. When, as the source text is passed from left to right, the end of the input stream of tokens is encountered, and the parser is unable to parse the input token stream as a single instance of the goal non-terminal, then a semicolon is automatically inserted at the end of the input stream. When, as the source text is passed from left to right, a token is encountered that is allowed by some production of the grammar, but the production is a restricted production and the token would be the first token for a terminal or non-terminal immediately following the annotation, no line terminator here, within the restricted production, and therefore such a token is called a restricted token, and the restricted token is separated from the previous token by at least one line terminator. Then a semicolon is automatically inserted before the restricted token. Note: TV excludes the code units of line continuation while TRV includes them. CR, LF, and CR line terminator sequences are normalized to LF for both TV and TRV. An explicit template escape sequence is needed to include a CR or CR, LF sequence. 38. ECMA International 2024. However, there is an additional overriding condition on the preceding rules. A semicolon is never inserted automatically if the semicolon would then be passed as an empty statement or if that semicolon would become one of the two semicolons in the header of a for statement C14.7.4. Note the following are the only restricted productions in T. He grammar, update expression, yield, await, left-hand side expression yield await, no line terminator here, plus left-hand side expression yield await, no line terminator here, continue statement, yield, await, continue, no line terminator here, label identifier yield await, break statement, yield, await, break, no line terminator here, label identifier yield await, return statement, yield, await, return, no line terminator here, expression, plus in yield await, throw statement, yield, await, throw, no line terminator here, expression, plus in yield await, yield expression, in, await, yield, no line terminator here, assignment expression in, plus yield await, yield, no line terminator here, assignment expression in, plus yield await, arrow function, in, yield, await, arrow parameters yield await, no line terminator here, equals, concise body in, async function declaration, yield, await, default, async. No line terminator here. Function binding identifier yield await, formal parameters, yield, plus await, async function body, plus default, async. No line terminator here. Function, formal parameters, yield, plus await, async function body, async function expression, async. No line terminator here. Function binding identifier, yield, plus await opt, formal parameters, yield, plus await, async function body, async method, yield, await, async. No line terminator here. Class element name yield await, unique formal parameters, yield, plus await, async function body, async generator declaration, yield, await, default, async. No line terminator here. Function binding identifier yield await, formal parameters, plus yield, plus await, async generator body, plus default, async. No line terminator here. Function, formal parameters, plus yield, plus await, async generator body, async generator expression, async. No line terminator here. Function binding identifier, plus yield, plus await opt, formal parameters, plus yield, plus await, async generator body, async generator method, yield, await, async. No line terminator here. Class element name yield await, unique formal parameters, plus yield, plus await, async generator body, async arrow function, in, yield, await, async. No line terminator here. Async arrow binding identifier yield. No line terminator here. Equals, async concise body in, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await. No line terminator here. Equals, async concise body in, ECMA International 2024 239. Async arrowhead, async. No line terminator here. Arrow formal parameters, yield, plus await. The practical effect of these restricted productions is as follows. When a plus plus or token is encountered where the parser would treat it as a postfix operator, and at least one line terminator occurred between the preceding token and the plus plus or token, then a semicolon is automatically inserted before the plus plus or token. When a continue, break, return, throw, or yield token is encountered and a line terminator is encountered for the next token, a semicolon is automatically inserted after the continue, break, return, throw, or yield token. When arrow function parameter s are followed by a line terminator before it equals token, a semicolon is automatically inserted and the punctuator causes a syntax error. When an async token is followed by a line terminator before a function or identifier name or token, a semicolon is automatically inserted and the async token is not treated as part of the same expression or class element as the following tokens. When an async token is followed by a line terminator before a token, a semicolon is automatically inserted and the punctuator causes a syntax error. The resulting practical advice to ECMAScript programmers is a postfix plus plus or operator should be on the same line as its operand. An expression in a return or throw statement or an assignment expression in a yield expression should start on the same line as the return, throw, or yield token. A label identifier in a break or continue statement should be on the same line as the break or continue token. The end of an arrow function's parameter, s, and its equals, should be on the same line. The async token preceding an asynchronous function or method should be on the same line as the immediately following token. 2, 1, 0. 2 examples of automatic semicolon insertion. This section is non-normative. The source, 12. 3 is not a valid sentence in the ECMAScript grammar, even with the automatic semicolon insertion rules. In contrast, the source, 1, 2, 3 is also not a valid ECMAScript sentence, but is transformed by automatic semicolon insertion into the following 1, 2, 3, which is a valid ECMAScript sentence. The source, 4, A, B, 40, copyright sign, ECMA International 2024, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus B, is transformed by automatic semicolon insertion into the following, return, a plus B. The source, a equals B plus C, is transformed by automatic semicolon insertion into the following, a equals B plus C. The source, if a B else C equals D, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token, even though no production of the grammar applies at that point. Because an automatically inserted semicolon would then be passed as an empty statement. The source, a equals B plus C, D plus C print, is not transformed by automatic semicolon insertion, because the parenthesized expression that begins the second line can be interpreted as an argument list for a function call, a equals B plus C, D plus C print, in the circumstance that an assignment statement must begin with a left parenthesis. It is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2, 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024 241. ECMAScript programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMAScript, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMAScript. 2, 1, 0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending in expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square bracket. Without a semicolon, the two lines together are treated as property, access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding binary operator, a regexp literal. Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3, 2 cases of automatic semicolon insertion and no line terminator here. This section is non-normative. ECMAScript contains grammar productions which include no line terminator here. These productions are sometimes a means to have optional operands in the grammar. Introducing a line terminator in these locations would change the grammar production of a source text by using the grammar production without the optional operand. The rest of this section describes a number of productions using no line terminator here in this version of ECMAScript. 2, 1, 0, 3, 2, 1 list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions. 15.8. with relation to function definitions. 15.2. 42. ECMA International 2024. 13. ECMAScript language. Expressions. 3.1. Identifier syntax. Identifier reference. Yield. Await. Identifier. Yield. Yield. Await. Await. Binding identifier. Yield. Await. Identifier. Yield. Await. Label identifier. Yield. Await. Identifier. Yield. Yield. Await. Await. Identifier. Identifier name but not reserved word. 3. 1. 1. Static semantics. Early errors. Binding identifier. Identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference. Yield. Binding identifier. Yield. Label identifier. Yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference. Await. Binding identifier. Await. Label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference. Yield. Await. Identifier. Binding identifier. Yield. Await. Identifier. Label identifier. Yield. Await. Identifier. It is a syntax error if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2. Static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions. Identifier name, identifier start, identifier name, identifier part. Let id text unescape be identifier code points of identifier name, return code points to string. Id text unescaped. Identifier reference. Yield. Binding identifier. Yield. Label identifier. Yield. Return yield. Identifier reference. Await. Binding. G identifier. Await. Label identifier. Await. Return await. Identifier. Identifier name but not reserved word. Return the string value of identifier name. Private identifier. Identifier name. Return the string concatenation of 0 times 0023, number sign, and the string value of identifier name. Module export name. String literal 1. Return the SV of string literal. Note string value of identifier name normalizes any Unicode escape sequences in identifier name, hence such escapes cannot be used to write an identifier whose code point sequence is the same as a reserved word. 44. ECMA International 2024 131. 3. Runtime semantics. Evaluation. Identifier reference. Identifier. Return. Resolve. Binding. String value of identifier. Identifier reference. Yield. Return. Resolve. Binding. Yield. Identifier reference. Await. Return. Resolve. Binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2. Primary expression syntax. Primary expression. Yield. Await. This identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await, expression plus in yield await, expression plus in yield await, dot, binding identifier yield await, dot, binding pattern yield await, expression plus in yield await, binding identifier yield await, expression plus in yield await, binding pattern yield await. Note 2 in non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2004-245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, yield await. The interpretation of capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, is refined using the following grammar. Parenthesized expression, yield, await, expression, plus in yield await. 3, 2, 1. At this keyword. 3, 2, 1. 1 runtime semantics. Evaluation. Primary expression. This. Return. Resolve this binding. 3, 2. 2 identifier reference. C13.1 for identifier reference 1 3, 2. 3 literals. Syntax. Literal. Null literal. Boolean literal. Numeric literal. String literal. 3, 2, 3. 1 runtime semantics. Evaluation. Literal. Null literal 1. Return null. Literal. Boolean literal. If Boolean literal is the token false, return false. If Boolean literal is the token true, return true. Literal. Numeric literal. Return the numeric value of new. Numeric literal is defined in 1 2 9 3. Literal. String literal. Return the SV of string literal is defined in 1 2 9 4 2 46. ECMA International 2024 1 3 2 4. Array initializer. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax. Array literal. Yield. Await. Elision opt. Element list yield await. Element list yield await. Elision opt. Element list. Yield. Await. Elision opt assignment expression. Plus in yield await. Elision opt spread element yield await. Element list yield await. Elision opt assignment expression. Plus in yield await. Element list yield await. Elision opt spread element yield await. Elision. Spread element. Yield. Await. Dot. Assignment expression. Plus in yield await. 1 3 2 4. 1 runtime semantics. Array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note. The above step throws if len exceeds 232. 1. Return len. Elision. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision naught assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision naught spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Element list. Elision naught assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus 1. Element list. Element list. Elision naught spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return next index. See perform. Create data property or throw array to string next int x. Next. D set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision naught. Let array be. Array create 0. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. Let array be. Array create 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision naught. 2. Let array be. Array create 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. plus in yield await. Property name, yield, await. Literal property name, computed property name yield await. Literal property name, identifier name, string literal numeric literal, computed property name, yield, await. Assignment expression, plus in yield await. Cover initialized name, yield, await. Identifier reference yield await. Initializer, plus in yield await. Initializer, in, yield, await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an obj. Act initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign, ECMA International 2024 249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition, method definition, bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In, used as a cover grammar for object assignment pattern and may be recognized as part of a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, or capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Property definition, cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object initializer. The object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation. Object literal. Return ordinary. Object create. Percent. Object prototype. Percent. Object literal. Property definition list. Property definition list. Let obj be ordinary. Object create. Percent. Object prototype. Percent. Perform. Property definition. Evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return. To string. NBR. Computed property name. Assignment expression. Let exp value be. Evaluation of assignment expression. Let prop name be. Get value. Exp value. Return. To property key. Prop name. 3, 2, 5. 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition. Perform. Property definition evaluation of property definition list with argument object. Perform. Property definition evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let exp value be. Evaluation of assignment expression. Let from value be. Get value. Exp value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let exp value be. Evaluation of identifier reference. Let prop value be. Get value. Exp value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse. See step 7 of JSON parse. Then, a let is proto set to be false. Else if prop key is proto and is computed property key of property name is false. Then a let is proto set to be true. Else, a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter as false. Then a let prop value be. Named evaluation of assignment expression with argument prop key. Else, a let exp value ref be. Evaluation of assignment expression be let prop value be. Get value, exp value ref. If is proto setter is true. Then, if prop value is an object or prop value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop key. Prop value 0. Return unused. Property definition. Method definition. Perform. Method definition evaluation of method definition with arguments, object and true. Return unused. 3, 2, 6 function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7 regular expression literals syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression, regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let V be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then a let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern text U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return regexp create pattern flags. 3, 2, 8 template literal syntax. Template literal yield await tagged no substitution template. Substitution template yield await tagged. Substitution template yield await tagged template head expression plus and yield await. Template spans yield await tagged. Template spans yield await tagged template tail. Template middle list yield await tagged template tail. ECMA International 2024 253. Template middle list yield await tagged template middle expression plus and yield await. Template middle list yield await tagged template middle expression plus and yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal yield await tagged no substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence. Template literal yield await tagged substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument force is greater than or equal to 232. Substitution template yield await tagged template head expression plus and yield await template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans yield await tagged template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, to static semantics. Template strings. The syntax directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw. Substitution template. Template head expression template spans. Let head be template string. Template head. Raw. Let tail be template strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans. Template tail. Return template string. Template tail. Raw. Template spans. Template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string. Template tail. Raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list. Template middle expression 1. Return template string. Template middle. Raw. Template middle list. Template middle list template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string. Template middle. Raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics. Template string. Template token. Raw. The abstract operation template string takes arguments template token. A no substitution template parse node. A template head parse node. A template middle parse node. Or a template tail parse node. And raw. A boolean. And returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token. Else a let string be the TV of template token. Return string. 3, 2, 8, 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert count 232 1. Let template be array create count 0. Let raw obj be array create count 1. Let index be 0 2. Repeat while index count a let prop be to string. Index B let cooked value be cook strings. Index C perform. Define property or throw. Template prop. Property descriptor. Cooked value. Writable. False. True. False. D let raw value be the string value raw strings. Index E perform. Define property or throw. Raw obj. Prop. Property descriptor. Raw value. False. True. False. F set index index plus 1. 3. Perform. Set integrity level. Raw obj. Frozen. 4. Perform. Define property or throw. Template. Raw. Property descriptor. Raw obj. False. Enumerable. False. False. 5. Perform. Set integrity level. Template. Frozen. 6. Append the record. Template literal. Template. To realm. 7. Return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 1.3.2.8.5 Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Capital R. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let precede and be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3, 2, 8, 6 Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1.2.9.6. Substitution template. Template head expression template spans. Let head be the TV of template head as defined in 1.2.9.6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3 future editions of this specification may define additional non-enumerable properties of template objects. Note 1 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1.2.9.6. Template spans. Template middle list. Template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1.2.9.6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1.2.9.6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1.2.9.6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9 the grouping operator. 3, 2, 9. 1 static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2 runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N return. Evaluation of expa parenthesized expression return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type-off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus and yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged super property yield await. Meter property new member expression yield await. Arguments yield await. Member expression yield await. Private identifier super property yield await. Super expression plus and yield await. Super identifier name meter property new target import meter new target import meta new expression yield await. Member expression yield await. New expression yield await. Call expression yield await. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R yield await. Super call yield await. Import call yield await. Call expression yield await. Arguments yield await. Call expression yield await. Expression plus and yield await. Call expression yield await. Identifier name call expression yield await. Template literal yield await. Plus tagged call expression yield await. Private identifier super call yield await. Super arguments yield await. Import call yield await. Import assignment expression plus and yield await. Arguments yield await. Argument list yield await. Argument list yield await. 58 ECMA International 2024 argument list yield await. Assignment expression plus and yield await. Dart assignment expression plus and yield await. Argument list yield await. Assignment expression plus and yield await. Argument list yield await. Assignment expression plus and yield await. Optional expression yield await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain yield await. Arguments yield await. Expression plus and yield await. Identifier name template literal yield await. Plus tagged. Private identifier optional chain yield await. Arguments yield await. Optional chain yield await. Expression plus and yield await. Optional chain yield await. Identifier name optional chain yield await. Template literal yield await. Plus tagged. Optional chain yield await. Private identifier left hand side expression yield await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax when processing an instance of the production call expression cover call express iron and a sync arrowhead. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, is refined using the following grammar. Call member expression yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1 1 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A.B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3.2 property accesses. Note properties are accessed by name using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3 3 2 1 runtime semantics. Evaluation. Member expression, expression. Let base reference be. Evaluation of member expression. Let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, base value, expression, strict, 60. ECMA International 2024. Member expression, identifier name, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, base value, identifier name, strict member expression, private identifier, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. Let field name string be the string value of private identifier. Return make private reference. Base value, field name string. Call expression, expression. Let base reference be. Evaluation of call expression, let base value be. Get value, base reference. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. Return. Evalu, A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R E S S, value, expression, strict, call expression, identifier name, let base reference be, evaluation of call expression, let base value be, get value, base reference, if the source text matched by this call expression is strict mode code, let strict be true, else let strict be false, return, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict, call expression, private identifier, let base reference be, evaluation of call expression, let base value be, get value, base reference, let field name string be the string value of private identifier, return make private reference, base value, field name string, 3, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, base value, expression, strict, the abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict, the abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. Let property name string be string value of identifier name. Return the reference record. Base value, property name string, strict, empty. ECMA International 2024 261 133 5 Then new operator 3 5 1 runtime semantics. Evaluation, new expression, new expression. Return. Evaluate new expression, empty. Member expression, new member expression. Arguments 1. Return. Evaluate new member expression. Arguments 3 5 1 1. Evaluate new. Construct expa. Arguments The abstract operation evaluate new takes arguments construct expa, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expa. Let constructor be. Get value, ref. If arguments is empty, then a let arglist be a new empty list for. Else a let arglist be. Argument list evaluation of arguments. If is constructor is false. Throw a type error exception. Return. Construct. Constructor. Arglist. 1 3 3 6 function calls. 3 3 6 1 runtime semantics. Evaluation. Call expression. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Let expa be the call member expression that is covered by capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Let member expa be the member expression of expa. Let arguments be the arguments of expa. Let ref be. Evaluation of member expa. Let func be. Get value, ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value, func %eval is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position, this call. Return. Evaluate call, func, ref, arguments, tail call, a call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value, ref. Let this call be this call expression. Let tail call be as in tail position, this call. Return. Evaluate call, func, ref, arguments, tail call. 62. ECMA International 2024. 133 2 Evaluate call, func, ref, arguments, tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then if is property reference, ref, is true, then I let this value be get this value, ref, be else. I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object. Else, let this value be undefined. Let arglist be. Argument list evaluation of arguments. If func is not an object, throw a type error exception. If is callable, func is false. Throw a type error exception. If tail position is true, perform prepare for tail call. Return. Call, func, this value, arglist. 3 3 7th SOP keyword. 3 3 7 1 runtime semantics. Evaluation super property. Super expression. Let env be get this environment. Let actual this be env get this binding. Let property name reference be. Evaluation of expression. Let property name value be. Get value, property name reference. Let property key be. To property key, property name value. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super propert. Y. Super. Identifier name. Let env be get this environment. Let actual this be env get this binding. Let property key be string value of identifier name. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super call. Super arguments. Let new target be get new target. Assert. New target is an object. Let fun be get super constructor. Let arglist be. Argument list evaluation of arguments. If this constructor, func, is false, throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser be get this environment. Perform the ser bind this value. Result. Let f be the ser 0. Assert. F is an ECMAScript function object. 1. Perform. Initialize instance elements. Result. F2. Return result. ECMA International 2024 263 1337. To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. Let envrec be get this environment. Assert. Envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMAScript function object. Let superconstructor be active function. Return superconstructor. 3. 7. 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this. An ECMAScript language value. Property key. A property key. And strict. A boolean. And returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. Let env be get this environment. Assert. Env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3 8. 1 runtime semantics. Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let ref be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return list. C. Append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return preceding args. C append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let cite obj be get template object. template literal, return site obj, template literal, substitution template. Let template literal be this template literal. Let site obj be get template object, template literal. Let remaining be argument list evaluation of substitution template. Return the list concatenation of site obj and remaining substitution template. Template head expression template spans. Let first subref be evaluation of expression. Let first sub be get value. First subref. Let rest sub be substitution evaluation of template spans. Assert rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 9 optional chains. 9 1 runtime semantics. Evaluation optional expression. Member expression optional chain. Let base reference be evaluation of member expression. Let base value be get value. Base reference. If base value is either undefined or null, then a return undefined. Return chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be evaluation of call expression. Let base value be get value. Base reference. If base value is either undefined or null, then a return undefined. Return chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accessors and function calls, the first of which begins with the token ECMA International 2024 265. Optional expression. Optional expression optional chain. Let base reference be evaluation of optional expression. Let base value be get value. Base reference. If base value is either undefined or null, then a return undefined. Return chain evaluation of optional chain with arguments base value and base reference. 9 2 runtime semantics. Chain evaluation. The syntax directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict optional chain. Identifier name. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be chain evaluation of optional chain with arguments base value and base reference. Let new value be get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital E X P R, new value, expression, strict, optional chain, optional chain. Identifier name, let optional chain be optional chain, let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value, new reference. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S, capital W I T H, capital I D E N, new value, identifier name, strict, 66, ECMA International 2024, optional chain, optional chain. Private identifier, let optional chain be optional chain, let new reference be. Chain evaluation of optional chain with arguments base value and base reference, let new value be. Get value, new reference. Let field name string be the string value of private identifier. Return make private reference. New value. Field name string. The 3rd of March 2010 import calls. 3.3.1.0. 1 runtime semantics. Evaluation. Import call. Import. Assignment expression. Let referrer be get active script or module. If referrer is null, set referrer to the current realm record. Let argraph be. Evaluation of assignment expression. Let specify be. Get value, rgraph. Let promise capability be. New promise capability, %promise %. Let specifier string be completion. To string. Specifier, if abrupt reject promise. Specifier string, promise capability, perform host load imported module. Referrer. Specifier string, empty, promise capability, return promise capability. 3.3.1.0.1. 1 continue dynamic import, promise capability, module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call as appropriate. It performs the following steps when called. If a module completion is an abrupt completion, then a perform call promise capability undefined. Module completion be return unused. Let module be module completion. Let load promise be module load requested modules. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined. Reason be return unused. Let onRejected be create built-in function. Rejected closure 1. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and onRejected and performs the following steps when called. A let link be completion. Module link be if link is an abrupt completion, then I perform call promise capability undefined. Link 2. Return unused. C let evaluate promise be module evaluate. D let fulfilled closure be a new abstract closure with no parameters that captures module and promise capability and performs the following steps when called. I let namespace be get module namespace. Module 2. Perform call promise capability undefined. Namespace 3. Return unused. E let unfulfilled be create built-in function. fulfilled closure, 0, F perform promise then, evaluate promise, on fulfilled, on rejected, G return unused, link and evaluate B create built-in function, link and evaluate closure, 0, let perform promise then, load promise, link and evaluate, on rejected, return unused. ECMA International 2024 267. The 13th of March 2011 tag templates. 3.3.1.1. 1 runtime semantics. Evaluation. Member expression template literal. Let tag ref be. Evaluation of member expression. Let tag fun be. Get value. Tag ref. Let this call be this member expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression template literal. Let tag ref be. Evaluation of call expression. Let tag func be. Get value. Tag ref. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. The 3rd of March 2012 meta properties. 3.3.1.2. 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meta. Let module be get active script or module. Assert. Module is a source text module record. Let import meter be module. If import meter is empty, then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module. C for each record. P of import meter values. Do. I perform. Create data property or throw. Import meter. P. D perform host finalize import meter. Import meter. Module. E set module to import meter. F return import meter. Else. A assert. Import meter is an object. B return import meter. 3.3.1.2. 1 host get import meter properties. Module record. The host defined abstract operation host get import meter properties takes argument module record, a module record, and returns a list of records with fields, an ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1.3.2.8. The actual arguments include a template object 1.3.2.8.4. and the values produced by evaluating the expressions embedded within the template literal. 68. Copyright sign. ECMA International 2024. 1.3.3.1.2.1. 2 host finalize import meter. Module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, and module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, 1.3.4.1 static semantics, early errors, update expression, left-hand side expression no line terminator here, no line terminator here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3.4. 2 postfix increment operator 1.3.4.2. 1 runtime semantics. Evaluation. Update expression. Left-hand side expression ++. Let LHS be. Evaluation of left-hand side expression. Let old value be the numeric. Get value, LHS, if old value is a number. Then, let new value be number. Add old value. 1. Else, assert old value is a big int. B. Let new value be big int. Add old value. 1z. Perform. Put value, LHS, new value. Return old value. ECMA International 2024 269. 1 3 4 3 postfix decrement operator 1 3 4 3 1 runtime semantics. Evaluation. Update expression. Left-hand side expression. Let LHS be. Evaluation of left-hand side expression. Let old value be the numeric. Get value, LHS, if old value is a number. Then, let new value be number. Subtract old value. 1. Else, assert old value is a big int. B. Let new value be big int. Subtract old value. 1z. Perform. Put value, LHS, new value. Return old value. 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics. Evaluation. Update expression. Plus unary expression. Let x be. Evaluation of unary expression. Let old value be the numeric. Get value, exper, if old value is a number. Then, let new value be number. Add old value. 1. Else, assert old value is a big int. B. Let new value be big int. Add old value. 1z. Perform. Put value, exper, new value. Return new value. 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics. Evaluation. Update expression. Unary expression. Let x be. Evaluation of unary expression. Let old value be the numeric. Get value, exper, if old value is a number. Then, let new value be number. Subtract old value. 1. Else, assert old value is a big int. B. Let new value be big int. Subtract old value. 1z. Perform. Put value, exper, new value. Return new value. 70. ECMA International 2024. 13.5 Unary operators syntax. Unary expression. Yield. Await. Update expression. Yield await. Delete unary expression. Yield await. Void unary expression. Yield await. Type of unary expression. Yield await plus unary expression. Yield await. Unary expression. Yield await. Unary expression. Yield await. Unary expression. Yield await plus await. Await expression. Yield. 3 5 1 delete operator. 3 5 1 1 static semantics. Early errors. Unary expression. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression. Member expression. Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. Or optional chain. Optional chain. Private identifier. It is a syntax error if the derived unary expression is primary expression. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N and capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N ultimately derives a phrase that if used in place of unary expression would produce a syntax error according to these rules. This rule is recursively applied. 3 5 1 to runtime semantics. Evaluation. Unary expression. Delete unary expression. Let ref be. Evaluation of unary expression. If ref is not a reference record, return true if is unresolvable reference, ref, is true, then A assert, ref is false. B return true if is property reference, ref, is true, then A assert, is private reference, ref, is false. B if is super reference, ref, is true. Throw a reference error exception. C let base obj be to object, ref. D let delete status be base obj, ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. Else a let base be ref. B assert, base is an environment record. C return base delete binding, ref. The last rule means that expressions such as delete foo produce early errors because note of recursive application of the first rule. ECMA International 2024 271. Note 1 when a delete operator occurs within strict mode code. A syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note 2 the object that may be created in step 4c is not accessible outside of the above abstract operation in the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. 3, 5, 2 avoid operator. 3, 5, 2, 1 runtime semantics, evaluation, unary expression, void unary expression, let x be. Evaluation of unary expression, perform. Get value, exper, return undefined. 3, 5, 3 the TPF operator. 3, 5, 3, 1 runtime semantics, evaluation, unary expression, type of unary expression, let val be. Evaluation of unary expression. If val is a reference record, then if is unresolvable reference, val is true, return undefined. Set val 2. Get value, val. If val is undefined, return undefined. If val is null, return object. If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a big int, return bigint. 1. Assert, val is an object. 2. Note, the step is replaced in section B. 3, 6, 3. 3. If val has an internal slot, return function. 4. Return object. 3, 5, 4 unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 1, 3, 5, 4, 1 runtime semantics. Evaluation. Unary expression plus unary expression. Let x be. Evaluation of unary expression. Return to number. Get value, exper. 3, 5, 5 unary operator. 3, 5, 5, 1 runtime semantics. Evaluation, unary expression, let x be. Evaluation of unary expression, let old value be. Numeric. Get value, exper. If old value is a number, then a return number, unary minus, old value 4. Else, ab, assert. Old value is a big int. Return big int, unary minus, old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0, note, produces minus 0, and negating minus 0 produces plus 0. Bitwise not operator, unary expression, 3, 5, 6, 3, 5, 6, 1 runtime semantics. Evaluation, let x be. Evaluation of unary expression, let old value be. Numeric. Get value, exper. If old value is a number, then a return number, bitwise not, old value 4. Else, ab, assert. Old value is a big int. Return big int, bitwise not, old value. Logical not operator, unary expression, 3, 5, 7, 3, 5, 7, 1 runtime semantics. Evaluation, let x be. Evaluation of unary expression, let old value be to boolean. Get value, Expa. If old value is true, return false. Return true. 3.6 exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273 136 1 Runtime semantics. Evaluation. Exponentiation expression. Update expression. Exponentiation expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E. Update expression. Exponentiation expression. 3.7 multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponentiation expression yield await. Multiplicative expression yield await. Multiplicative operator. Exponentiation expression yield await. Multiplicative operator. 1 of percent 3 7 1 runtime semantics. Evaluation.
can't find the delete operator. Or I don't know. I have control flow macros somewhere. I have a delete operator somewhere. I don't have this, so I made like normal loop and save it to column. It's delete. So I got like the body of the loop. I'm gonna run it. I probably missed something. I'm just gonna see if it builds and runs. And I don't know. I guess I gotta like print the time. I think I'm gonna like finish this up tomorrow. This bug's about to go. Building again. I didn't even hit save. Maybe I clicked build. Oops. Dang it. Close rock one. Okay, I don't know. I'm gonna run it, see if it builds or not. Use up 2 gigs? Holy shit. I gotta like optimize for sparse arrays. Maybe it didn't use 2 gigs. I don't know, Windows is like stuck at 8 gigs, unless it was already 8. Oh man. The logout's too big to catch the output. That's great. That's a lot of work. I'm gonna have to like I don't wanna grab what's going to the console to another standard out or another file directory or file descriptor. And I don't think I can like leave it and switch the file descriptor from the console log out to a file. Maybe it won't reset. And I'm gonna have to like debug it as it runs this way. So I'm done for now. This will be a whole thing tomorrow. That's cool. It's got like 90% of it. It's close enough. I can't even, I gotta turn off what it logs to the console too, to like actually speed test it. I can't speed test it if it's printing to the console. Like make a note, and then that's it. No, dang it. It's not worth sleeping. so I'm pretty sure I'm gonna get it tomorrow. But after I get it, whatever. I'm ready to the standard. After I convert 64-bit, make this standard. Before I go to standard.